Hello students, today we're going to be talking about real-world application of equations. Go ahead and write down in your table of contents that this page that you picked up right when you walked in is page 119, and go ahead and number this page as well in the top right hand corner. Okay, so today with this notes page, we're just going to go through each of these word problems and work them out together. The goal is to be able to be given a situation, write the following equation that fits that situation, and then solve it. So we're going to look at question number 14 first. It says, Micah and his brother found some cash at a bus stop. Okay, there's no pertinent information in this sentence other than our context. They're just laying down the situation for you. So we got two brothers who found some cash at a bus stop. They split the money evenly. So that's our first indication as to what we're going to do in this problem. If they're splitting something evenly, then that means that they would end up dividing by 2. They're cutting whatever they have in half. So that means this is going to be a division equation. And it says each is getting $16. So that is automatically our total. $16. Now it says how much money did they find? So the how much money is going to be our variable. And I'm going to put an M for money. Now, I know that they have how much they're going to be getting evenly. So that's the total. Now, they got a lump sum of money, right? We don't know what that money is, but we do know that it is being divided by 2, coming out to 16 per brother. So in order to solve this problem, in order to solve for m, I'm going to have to do my inverse operation, which is multiplication, because right now m is being divided by 2. So that means I'm going to multiply by 2 on both sides, canceling out my 2's over here, leaving my m by itself, which is equal to 16 times 2. Now 16 times 2, 2 times 6 is 12. I'm going to carry my 1, 2 times 1 is 2, plus that 1 I carried over is 3, giving me a total of 32 for m. Now I know that this is correct because if I take that total amount of money that they found at the bus stop, $32, and I plug it back into my equation for m divided by 2 is 16, therefore making my equation true for this situation. Moving on to question number 15. It says a large box of cereal costs $3.50. Okay, that's my total cost for my large box of cereal. How many boxes can you purchase with $28? So my $28 is my total amount of money. So we've got $28 over here. Now, it says one large box of cereal costs $3.50. So that's my cost per unit, so per box of cereal. Now, I'm going to go ahead and take that cost per cereal box, and I'm going to multiply it with my number of boxes. So I'm just going to put B for box, okay? Cost per box, $3.50, times the total number of boxes would get me my $28 that can be purchased or can be used to purchase your boxes of cereal. Now, in order to solve this, right now, 3.5 is being multiplied with B, and I want to take my total amount of money and divide it by my cost per box. So that means I'm going to divide both sides by 3.5, leaving my number of boxes by itself. And I'm going to go ahead and take 28 and divide it by 3.5. Now, I cannot have a decimal in my divisor. I have to multiply it by 10 to move it over, making me add a 0 to this number. Now, 35 can go into 28 0 times, but it can go into 280 8 times. When you take 35 and multiply it by 8, you get exactly 280 with nothing left over. So therefore, my number of boxes would be 8. took my cost per box and divided it by my total amount of money spent, which was $28, in order to get my number of boxes. And if I plug in 8 back into my equation, 3.5 times 8 would get me my $28. So I know I did it right. Moving on to question number 16. Jada swam 20 meters more than Molly. Okay, so that information is important. 30 meters more than Molly. Jada swam a total of 800 meters, That's her total. How many meters did Molly swim? So we're looking for how many meters Molly swam. I'm going to go ahead and put M for my variable there, as in the miles for Molly. So 800 is going to be my total of meters that I know. And I know that Jada swam 200 meters more than Molly. So whatever Molly's amount is going to be added. There's going to be a 200 meters added to it because Jada swam 200 meters more than Molly's amount. So now, in order to solve for how far Molly swam, we're going to have to do the inverse operation. Right now, there's a plus 200 with my variable. I'm going to isolate my variable by doing the opposite operation, leaving my variable all by itself. And I got to do the same thing on this side, getting 600. So Molly's miles would be 600 plus the 200 meters more that Jada swam would get me a total of 800 meters. So I know I did the problem right. Moving on to question number 17. A recipe calls for 2.5 cups of sugar. Okay, that's important. We'll underline that information. You have already added 0.7 cups. How many more cups of sugar do you need to add? So we're looking for more cups of sugar. I'm going to put C as my variable. So let's break this down. For the recipe itself, it calls for a total of 2.5 cups. So that's going to be my total amount of sugar. We have already started with 0.75 cups. Okay, now it says how many more cups of sugar. So that means that we would be adding our amount of cups of sugar that we're looking for to what we already have in order to get a total of 2.5. Now, in order to get rid of this 0.75 that's with my variable, so I know my value of my cups, I'm going to have to subtract this amount from both sides to get C by itself. And I'm going to line up my decimals because I'm subtracting decimals and add a 0 there. I know I cannot subtract 5 from 0, so I'm going to have to borrow. And I also cannot subtract 7 from 4, so I'm going to borrow from my 1 over here. 14 minus 7 is in fact 7. I'm going to bring my decimal down. And 1 minus 0 is 1. So the additional cups that I would have to add of sugar to my recipe would be 1.75. Now, if I add 1.75 to my 0.75 cups that were already added, I would get 2.5 or 2.5 cups. So I know that I set up my equation right and solved it correctly. Let's say check my answer. Okay. And last but not least, we're going to do number 18 together. 19 you're going to complete by yourself. Number 18 says Jefferson High School has an enrollment of 1,864 students. That sounds like a total to me. In May, 564 students will graduate. How many students will be enrolled after graduation? This problem is pretty straightforward. It's giving you a total number of students that have been enrolled and then a number of students that are going to graduate. So when kids graduate, they obviously leave. So that's that sounds like subtraction to me. And then we just need to know how many students will be enrolled after the graduation. So S is going to be my number of students that are going to be enrolled after graduation. I'm going to start with my number of students that I currently have, minus the kids that are going to graduate in order to get my number of students enrolled. So I'm going to do 1,864 minus 564. That's 0, that's 0. 8 minus 5 is 3. And I have 1,000 students left. So my students that will be left after graduation will be 1,300. Go ahead and do question number 19 by yourself, and then we'll talk about it together in just a couple of minutes. We'll review it together. Make sure you put this paper in your binder. You will not be turning this paper in today. It's going to stay in your binder as reference.